Hello, smart mathematicians. Let's do question 10.1. In the diagram, BE and CD are diameters of a circle having M as the center. Chord AE, this is a chord, is drawn to cut CD at F. AE is perpendicular to CD. You can see the angle here, the 90-degree angle here. And then let angle C be equal to X. Give a reason why AF is equal to FE. But now, before we answer the questions, I want us to discuss this rider like we usually do. I would like to encourage you to do this in the examination. Look at the rider using the information that you're given and fill in the rider as much as possible. Okay, that will assist you a lot. Let's use the information. BE and CD are diameters of a circle having M as the center. So from this we can see that BM is equal to ME because they are radii. Even CM is equal to MD there. So these four are equal. BM is equal to ME is equal to MC is equal to MD. BE is diameter, so meaning that this angle here is what? Is 90 degrees. Remember, an angle is subtended by diameter, an angle in the semicircle. Right? CD is also diameter, so meaning that this angle also, this one, is also 90 degrees. Okay, just filling in information as much as possible. This angle also is 90 degrees, angle in the semicircle. Right, if this angle is X here, X, this one should be 90 minus X. You see that? Because this angle is 90. This one is 90 here. This one is 90 is given. Right, if you check this angle, A1 is subtended at the circumference. Then M1 is this angle subtended by the same arc, CE, at the center. A1 is subtended by CE at the circumference. M1 is subtended by CE at the center. So M1 is 2 times A1. So it's going to be 180 degrees. So these are degrees minus 2x. You see that we have multiplied 90 times 2 and negative x times 2 there. So what about M1 and M3? They're vertically opposite angles. Vertically opposite angles are equal. If we check, M3 is subtended by BD at the center, and then A3 is subtended by BD at the circumference. So this is also 90 minus x. And 90 minus x. We're dividing 180 degrees minus 2x by 2. These are adjacent angles on a straight line. M2 and M1, they're adjacent angles on a straight line. So if you say 180 degrees minus 180 degrees minus 2x, you say 180 degrees minus 180 degrees minus 2x, what do you get? You get 2x. So meaning that this M2 is 2x, and also this one here is, we don't have the number here, it's also 2x. Okay, let's say EMD is 2x. We have done something that may assist us. We now understand the information. We now understand the writer. Let's go to our question. In the diagram, BE and CD are diameters of a circle having M as the center. Chord AE is drawn to cut CD at F here. Right, and then AE is perpendicular to CD. Let C be equal to X. Give a reason why AF is equal to FE. Okay, we didn't discuss this information, but let's try. Why may we have AF being equal to FE? If you check here, MC or MF is a line drawn from the center and is perpendicular to the chord. Do you see that? A line drawn from the center of a circle perpendicular to a chord bisects the chord. A line drawn from the center of a circle perpendicular to a chord bisects the chord. So we have this line here which is drawn from the center of the circle and is perpendicular to the chord. Okay, what does it do? It divides the chord into two equal parts, meaning that AF is equal to FE. So we have here AF is equal to FE because of the line from center perpendicular to chord. Okay, that's the reason why AF is equal to FE there. We are going to meet when we're doing question 10.2.